Hi everyone. So this video is about solving equations. It should be a review from Algebra 1, but it's one of those key concepts that we need to revisit each year so that we know we can move on. So by the end of this video, you will be able to solve multi-step algebraic expressions using opposite operations. So before, in expressions, we used PEMDAS. Now, we're going to use PEMDAS backwards. So that's what opposite operations. And we're going to be able to solve formulas for given variables. So we use the same concept with numbers, and now we transfer it to variables. We need to use that oftentimes when we're solving for y if we're graphing a line, which is our next video, or in the future when we're solving quadratic functions. So let's begin. The first step you have to do is, these are one-step equations. You have to identify what operation is going on. Well, now I'm solving for m. It says m minus 32 equals 18. So what I do, and what I advise you to do, is to draw a line through the equal sign. It kind of sets up those two sides. Now whatever is happening to the variable, that is what I'm going to do the opposite of. So m minus 32, now I'm going to add 32 on both sides, and that cancels because a negative 32 and positive 32 becomes 0, those opposite operations. So now m equals 18 plus 32, which is 50. For the next one, again I'm going to draw the line, and it's 22 plus p equals negative 12. Well, the first thing I need to identify is what's happening to p. Well, there's a plus sign. Okay, so p is positive. Well, what is this 22? If you just see a number, 22, that means there's an invisible plus, or a positive sign in front of it. So what I'm going to do is I'm going to take 22 away from both sides. Because what's the opposite of a positive 22? A negative 22. These cancel. I'm left with a positive p, so I can just write p equals. And a negative minus a number is more negative. I'm $12 in debt, and I go $22 more in debt, and now I'm at negative $34 in debt. So I'm going to come back to this equation in a second. It's the same process with multiplication and division. First step is to identify, is this multiplication or division? If you don't see an operation sign in there, it's multiplication. So what I'm going to do is I'm going to divide by negative 5 on both sides. Negative 5 divided by negative 5 is 1, so I can either write it as 1n or just n equals 60 divided by 5 is 12. A positive divided by a negative is a negative. Now I've solved that one. The trick comes when anyone sees fractions. Everyone loves fractions. So the trick with this is to solve it like a proportion. So the first step is to convert these mixed numbers into improper fractions. So to do that, I would do 2 times 3. 2 times 3 is 6, then add 1. So this becomes 7 over 2 p equals, and then I repeat the process. 2 times 1 plus 1 is 3 over 2. Now, the trick with this is you have to know, where does this p go? Well, in previous lessons, I talked about, well, this is really p over 1. So the p is actually going to go to the top. So it's 7p over 2 equals 3 over 2. Now, I can just cross multiply. I get 14p equals 6. I then divide by 14. I get 6 over 14, but I never leave a fraction like that because they're both even. So I can reduce this to 3 over 7. And that is my answer. Now, those are what we call one-step equations because really we're only doing one step to solve them. In these next ones, we're doing 2 steps, or multi-step equations. So in this case, I am solving for x. The trick with this is I have to start PEMDAS backwards. So I have to start with that addition or subtraction first. Well, oftentimes students say, well, I'm subtracting 8, so I'm going to add 10 on both sides. Well, that's not the sign of 10. We talked about it before. This is 10 minus 8x. So that 8 is negative. The 10 is actually positive. So what I'm going to do is I'm going to get rid of this 10 first. So I'm going to subtract 10 on both sides. You notice I'm getting rid of the stuff farthest away from the x first. That's generally what you have to do. The farther away from x is, the first thing you have to get rid of. So these 10s cancel. I'm left with 40. Now, oftentimes, this is the key mistake that students make. Minus 8x, they just bring down an 8x. What is the sign in front of that? That's a negative. So what I do, I divide by negative 8. That 8 is negative, so I have to carry that sign with it. Cancel that out. X equals negative 5, and I'm done. Now, the trick with this one, and we're going to get into more of this when we start graphing, is now we have to solve for y. Whenever you're solving for a variable, you're not going to get one number. So you see how it's 4x plus 5y equals 100. Whenever you have two variables, you're not going to be able to solve that equation. You're only going to be able to rearrange the numbers so that you can get one variable isolated. So in this case, I'm solving for y, so I'm going to underline it. I'm going to draw a line. Using that same logic that I used over here, what's farthest away from y on that same side of the equal sign? Well, that's 4x. I got to get rid of that 4x. What's the sign in front of it? Well, there is no sign, so it's positive. So to do that, I'm going to subtract 4x from both sides, because it's separated by that addition sign. So to move it, I got to subtract it. I'm left with 5y equals 100 minus 4x. Now I got to solve for y. So the 5 times y, I'm going to divide by 5. The trick with this, whenever I divide anything or multiply on both sides, I have to divide each thing individually. So what happens is I have to do 100 divided by 5, which is 20. And then I have to do 4 divided by 5, going to be a decimal, so I'm going to use fractions, minus 4/5 x. Now, if you remember back to y equals mx plus b, generally we don't write it like this. We write it like this. Now, what you have to see is this 20 positive, this 20 positive, this negative 4/5. This is negative 4/5. The signs transfer over. The minus sign does not just stay in its place. That minus sign is telling you what the sign of this number is. Is it positive or is it negative? So you have to carry that with it. The next step that I want to talk about is when you have multiple variables on the same side or on different sides of the equal sign. So in this case, I have a 5y and a 3y, but they're on opposite sides of that line. So the trick is I always move the smaller number first. Always move the variables first. That way it makes it easier. And if you move the smaller variable, it's going to be a lot easier because you're dealing with more positive numbers. So I'm going to move this 3y over here. To move something, I'm going to either add or subtract, depending on the side. This 3y is positive, so I'm going to subtract 3y from both sides. 3y minus 3y cancels out. So the only thing I'm left with is this 12 on this side. 5y minus 3y is 2y minus 8. Now, remembering back to the expressions piece, I can subtract these because they're like terms, but I can't touch the 8 because it doesn't have a y with it. You gotta follow those same rules. Now I fall back into a two-step equation where I have y, there's only one y in there, so now I'm going to add 8 on both sides. 2y equals 20. Now I divide by 2, y equals 10. And I've solved it. The next step I want to point out, it's the same process. I'm going to be moving y's from both sides. And I have to look. What is the smaller number? 8y or 3y? Well, I just made a mistake right there. It's 8y and negative 3y. That minus sign you have to think of as the sign of that number. That's a negative 3. So when I move it, I'm going to add 3y to both sides. So now these cancel out. What's left is a negative 11 equals 11y plus 1. Well, now plus 1, I'm going to get rid of that plus 1 by subtracting 1. I'm left with negative 12 equals 11y. I divide by 11. Y ends up being negative 12/11. And I can leave my answer like that. So please complete the rest of these practice problems on the next page and come to me with any questions. Thank you.